morning, everyone. Today, we are going to explore how modern AI can drive corporate success. This isn't about science fiction or distant futures. It's about practical, implementable AI solutions that are creating value for businesses right now. By the end of the session, you'll understand what AI really is, how it works, and most importantly, how to evaluate whether it makes sense for your specific business challenges. Let's start by clearing some confusion. You have probably heard AI, machine learning, and deep learning used interchangeably, but they are not the same thing. Think of it like this. Artificial intelligence is the broadest concept. It's any system that can perform tasks requiring human-like intelligence. Machine learning sits within AI and is actually the engine powering most modern AI systems. It is fundamentally about statistical algorithms that learn patterns from data rather than following explicit programming. Deep learning is just one specific type of machine learning. Neural networks with many layers. It has got a lot of press, but it's important to understand it's just one tool in the toolbox, not the AI itself. And the key takeaway here, when someone pitches you to an AI solution, they are almost certainly talking about machine learning under the hood. Now let's talk about what AI can and cannot do. Current AI, what we call as narrow AI, excels at specific tasks. Self-driving cars which navigate roads, a cancer detection system that can analyze medical images brilliantly, customer services chatbots, recommendation systems. Artificial general intelligence would be a system that can do everything humans can do cognitively. Walk into any house and make coffee, read a book and discuss it for hours, pass the Turing test consistently. But this is all still science fiction. We are likely decades away from this reality. Why does this matter for businesses? Because you need to match AI solutions to specific, well-defined problems. Don't expect one AI system to solve all your challenges. That's not how it works today. AI is not new. It's been evolving over the last 60 years. The field was born at the Dartmouth Summer Research Project in the 1950s. The 1960s gave us the perceptron, which became the foundation for neural networks. Through the 1980s and 90s, we were in the era of rule-based systems. Think early machine translation where programmers manually coded every rule. Now this was labor intensive and did not scale well. The mid-1990s brought us revolution. Statistical approaches. Instead of programming rules, we let algorithm learn patterns from data. Support vector machines became popular in the early 2000s across many domains. Then in 2007, Jeffrey Hinton's work on deep belief networks opened the door to modern deep learning. Here is what critical to understand. The current excitement isn't because we invented AI recently. It is because three things finally aligned. Massive amounts of data from everything we track digitally, powerful computational resources through GPUs and cloud computing, and algorithms sophisticated enough to use both efficiently. This convergence is what makes AI practical for businesses today. Now, before you invest heavily in artificial intelligence, you need to understand AI's history of boom and bust. AI winters occurred when hype exceeded reality. Unrealistic expectations led to disappointment, fundings dried up, and progress was stalled. So, might this time be different? Four reasons. Genuine data availability at unprecedented scale, computational power that was science fiction 20 years ago, proven business applications generating real ROI, and algorithms that actually deliver on specific problems. But here's my question to you. Not everything you read about AI in the press is real or applicable to your business. Be skeptical. Focus on proven use cases with measurable outcomes. If someone isn't clearly articulate the ROI, simply walk away. So what is real and what is overhyped? Let's get practical about what's actually working versus what is still aspirational. Getting close to reality. Self-driving cars work on highways and in limited city conditions. Medical images can detect cancer in specific scan types. Voice recognition understands commands reliably. Recommendation systems actually work. Netflix and Amazon prove this on a daily basis. Fraud detection operates in real time as well. But what is there not there yet? Having philosophical conversations with a human being for hours, replacing all customer service with chatbots, AI reading books and understanding like humans do, fully contextual dialogue systems, and general problem solving across any domain. And what are the critical insights? The same algorithm performs differently across problems. Computer vision for autonomous driving is much more mature than natural language understanding for open-ended conversations. Now evaluate each application independently. What are the key factors for AI solutions? When you're considering an AI solution, 6 factors must align. Number one, your data. Quality, quantity, and relevance all matter. Garbage in and garbage out applies doubly for AI. Second, the algorithm. Is there actually a viable machine learning approach for a specific problem? Third, speed requirements. A self-driving car needs millisecond response times. A customer service system might tolerate longer processing times. Fourth, your problem type. Is this a marketing, a sales, or an operational issue? Each one will have different characteristics. Fifth, what is your industry? And this is very crucial. If you are in a banking or insurance, deep learning's black box problem becomes serious. Regulated industries often need to explain decisions, and some AI methods can't do that well. Sixth, explainability. Can you articulate why the AI made a particular decision? In some contexts, this is not negotiable. Understanding your data. Data comes in two fundamental types, and this dramatically affects your AI strategy. Structured data fits neatly into rows and columns, Excel spreadsheets, database tables, sales numbers, customer demographics. This is easier and faster to work with for AI. If you are starting your AI journey, begin here. Unstructured data is everything else: text documents, images, videos, audios, social media posts. Now, this requires pre-processing and feature extraction before you can use it effectively. Most business functions use both. Customer service has call records, unstructured text, and service upgrade data, structured records. Sales has email activity, but also CRM data in Salesforce. Marketing combines campaign metrics with social media content. Understanding what type of data you may have is step one in any AI project. There are three fundamental approaches to machine learning, and choosing the right one is critical. Supervised learning uses labeled data. You show the system thousands of examples. This patient has diabetes, this one does not, and it learns to predict for new cases. The requirement, you need those labels, which actually means human annotation. Then we have unsupervised learning, which finds patterns without labels. You don't tell what customer segments exist, it discovers them automatically from their purchasing behavior. No labels are needed, but you have less control over what it finds. And then we have what we call as the reinforcement learning, which learns through trial and error with feedback. Think of training a robot to navigate. If it tries movements, gets rewards for good ones and penalties for bad ones, and gradually optimizes its behavior. Now, each approach suits different business problems. Choose based on your data and your objectives. Let me explain reinforcement learning more concretely because it's less intuitive than the others. Imagine a robot system trying to navigate a room. This robot is the agent making decisions. The room is the environment it operates upon. Moving left, right, forward, backwards are the possible actions. When it finds water, it gets a positive reward. When it hits fire, it gets a penalty. Initially, the robot moves randomly. It goes right, hits fire, and learns that it's bad. Tries left, finds water, and learns that's good. Over thousands of trials, it optimizes its path to maximize rewards and minimize penalties. Now, this is powerful for dynamic environments where the right answer changes based on context, like optimizing pricing, managing inventory with fluctuating demand, or routing delivery vehicles through changing traffic. Now, within supervised learning, you'll encounter two more problem types. Regression predicts numbers. What will customer satisfaction scores be? What price will this house possibly sell for? What's the next quarter's revenue? These are the continuous numerical predictions. Classification predict categories. Is this email spam or not spam? Will this customer buy or not buy? Does this patient have disease A, B, or they are healthy? These are discrete category assignments. Within unsupervised learning, clustering is most important. Finding natural groupings in customer behavior, segmenting survey responses, identifying communities and networks, and detecting anomalies. Now, why does this matter? Because the problem type determines your algorithm choice. Define your problem clearly before selecting methods. It is one of the most common mistakes I see which businesses make. Let's synthesize what we have covered into actionable guidance. Essential understanding. Machine learning is the foundation of modern AI. Deep learning is one tool, not the solution to everything. Current AI is narrow and task specific. AGI is decades away. Data quality and quantity are make or break factors. Different algorithms perform differently across different problems. Now, before building an AI solution, follow this checklist. Assess your data, structured versus unstructured, quality versus quantity. Define the problem clearly. Is this classification, regression, or clustering? What are your success metrics? Consider industry constraints. What are your explainability requirements? Speed needs, accuracy trade-offs. Start small. Pilot with structured data and validate results before scaling. And remember, be skeptical of AI hype. Focus on proven narrow applications with clear business value. AI is a powerful tool for specific problems, and it's not a magic solution for just about everything. Now let's move from theory to application. Machine learning boils down to three core capabilities that map to business value. First is data to scores, which actually means building models that predict meaningful numbers, customer lifetime value, risk scores, satisfaction ratings, and revenue forecasts. Now we have data to classes, which actually talk about building models that categorize fraud versus legitimate transactions, high value versus low value customers, different document types. And the third is data to clusters. This talks about building models that group similar items without predefined categories, customer segmentation, market research groupings. Now, these are three concepts which apply across industries, whether they are customer service automation, financial service optimization, retail personalization, or healthcare transformation. And let's talk about each of them in detail. Data to scores. It means predicting numerical values with business meaning. You can feed in structured data like sales records, unstructured data like customer emails, images like product photographs or damage assessments, or video like security footages. Now, three powerful business applications. Sales forecasting. Predict revenue by region to optimize resource allocation. Customer satisfaction predicts which complaints will escalate so that you can intervene early. Insurance claims that they assess car damages repair costs from photos instead of sending adjusters to each and every claim. Now, the key here is that output is a number you can act upon. It is not just will this happen, it is how much and how likely and of what value. Let me show you a real world data to scores application, and that's what we'll term as sentiment detection. And the problem is we are receiving thousands or millions of customer communications, emails, support tickets, social media posts, chat logs, and product reviews. And you need to assess customer happiness at a scale. And the solution to build a model that outputs a sentiment score from very negative, which is -1, to +1, which is very positive for each communication. And the business value, scale, process millions of messages efficiently, speed, real-time tracking and alerts, insights, identify trending issues before they escalate, resource optimization, prioritize human attention on the most critical negative sentiment cases. So this is AI creating practical business value, not replacing humans, but helping them focus on what matters most. Now, whether you are building internally or evaluating a vendor, every machine learning project should follow this systematic process. And this is basically a 7-step machine learning model building process. Step 1 is to define this target action. Be specific about what you are predicting and how you will use it in decision making. Vague objectives, they kill projects. Step 2 is collect data. Gather sufficient, relevant, high quality data. This is often the hardest part. Step 3, label data. For supervised learning, you need humans to annotate examples with the correct answers. Step 4, extract features. Identify the patterns and characteristics in the data that are actually predictive. Step 5, choose algorithm. Select the appropriate machine learning technique based on your data type, volume, and problem complexity. Step 6, train the model. Use your labeled data to build the predictive model and optimize its parameters. And lastly, the most important step, test your model. Evaluate performance on completely new unseen data to ensure that actually it works. Now each step builds on the previous one. Skipping steps leads to failure. This framework ensures systematic, value creating machine learning solutions. Classification assigns data to specific categories instead of predicting numbers. This enables direct actionable decisions. Email classification automatically route incoming messages to support, sales, billing, or other departments, and no human sorting is required. Medical diagnosis classify patients as healthy, patients at risk, patients having disease A, or patients having disease B for early intervention. Four critical business applications are under consideration. One is fraud detection, flag transactions as legitimate or fraudulent in real time. Customer segmentation, classify as high, medium, or low value for targeted marketing. Quality control, automated pass-fail inspection on production lines. Document processing, automatically classify invoices, receipts, and contracts for routing. The power of classification is that the output directly determines the action. No interpretation is needed. The category is the decision. Clustering is fundamentally different. It's unsupervised learning that discovers groups without predefined labels. In customer behavior analysis, identify natural customer segments, discover purchasing patterns, find similar product preferences, optimize marketing strategies, all without telling the algorithm what to look for. In market research, segment service responses automatically, identify opinion groups, discover hidden preferences, and target messaging effectively. The key difference, no human labels are required. The algorithm automatically discovers groupings in your data. Business value comes from market segmentation. Discover customer groups you didn't know they ever existed. Anomaly detection. It identifies unusual patterns or outliers that might indicate frauds or errors. Recommendation systems. Group similar products or users for personalization. Operational efficiency. Optimize resource allocation based on discovered patterns. So this is exploratory AI, helping you discover insights rather than predicting predefined outcomes. Before you greenlight any AI project, use this decision framework, and that is termed as the AIDR. A stands for algorithm. Is there actually a viable machine learning approach for this problem? Not every problem is solvable with the current AI. Impact. Will solving this problem create measurable business value? If you can't quantify the benefit, don't start. D is for data. Do you have sufficient quality data to train the model effectively? Most projects fail here. R is for readiness. Is your organization actually ready to implement and maintain the solution? Do you have the infrastructure, skills, and change management capability? All four must align for success. One weak link and your project fails. Use this framework to evaluate and prioritize AI initiatives. It will save you from costly mistakes later. Deep learning deserves special attention because it's powerful but often misunderstood. What is it? Advanced machine learning using neural networks with multiple layers that automatically learn complex patterns, and it excels with large data sets. And when to use deep learning? When you have large amounts of data, when you need complex pattern recognition, traditional machine learning methods are insufficient, or you are working with images, text, or speech. Applications include complete computer vision for medical imaging, autonomous vehicles, facial recognition, natural language for translation, chatbots, sentiment analysis, speech recognition for voice assistants, and transcription, recommendation engines for content platforms and e-commerce. Business considerations, it requires significant computational resources. Think cloud GPU costs. You need large, high quality datasets, more than traditional machine learning. Development and training time is longer. It's more complex, but potentially delivers higher returns for right problems. Don't default to deep learning. Use it when simple methods won't work. The 2020s brought a revolution. Generative AI systems that understand and generate human-like text. ChatGPT from OpenAI excels at conversational AI, content creation, code generation, and problem solving. Use it for customer support, content marketing, training materials, and process documentation. Its strength is natural conversation and creative tasks. Cloud from Anthropic just focuses on analysis, reasoning, document processing, and ethical responses. It is particularly useful for research analysis, strategic planning, data interpretation, and compliance review. And its strengths are safety-focused design and nuanced reasoning. Perplexity specializes in real-time search with source citation. Use it for market research, competitive analysis, fact-checking, and trend monitoring. Its strength is accessing current data with transparent sourcing. And these aren't replacing traditional machine learning. They are adding conversational interfaces and generative capabilities to the AI toolkit. Let's talk about how these AI agents integrate into actual business workflows. For content and communication, generate reports, proposals, and marketing materials automatically. Automate personalized customer emails. Create training materials for employee onboarding. Handle multi-language translation. For analysis and decision support, interpret complex business data and trends. Conduct market analysis and competitive intelligence. Assess business decisions and risks. Research industry insights and regulatory requirements. There are some other notable tools. GitHub Copilot for programming, Jasper AI for marketing, Midjourney and Delhi for visual content, Notion AI for productivity, and Grammarly for writing enhancements. There are business impact metrics from early adopters. 20 to 40% time savings in content creation has been observed, 30 to 50% faster document processing, 25 to 35% improvement in customer response times also has been observed. And these are not theoretical. Companies are measuring these gains now. Financial services is seeing over $1 trillion in annual impact potential from AI. Front office applications, algorithmic trading analyzing market data in milliseconds, personalized customer service at scale, AI-powered investment advisory and portfolio management, sophisticated risk assessment for loans and insurance, back office operations, real-time fraud detection and prevention, automated regulatory compliance monitoring, document processing that takes seconds instead of days, faster and more accurate credit scoring and underwriting. And real examples, JP Morgan Chase's coin system, which processes legal documents in seconds that previously took lawyers 360,000 hours annually. PayPal's AI processes over 19 billion transactions with 99.5% fraud detection accuracy, and financial serves over 1 billion users with AI-powered services. And the impact here is not future-looking; it's happening right now at a massive scale. Retail is being transformed by AI on both customer-facing and operational fronts. Customer-facing, personalized product recommendations that actually work. Dynamic pricing that optimizes for demand and inventory. Visual search letting customers find products from images. Chatbots and virtual shopping assistants providing 24 by 7 support. Operational, Inventory management, predicting what to stock and where. Supply chain optimization, reducing costs and wastes. Accurate demand planning and prediction. Loss prevention and theft detection. And what are the success stories? Amazon generates 35% of revenue through its recommendation engine. Walmart's AI inventory management reduced stockouts by 30%. Sephora's virtual artist app drove 80% increase in online engagement. Stitch Fixes, it serves 3 plus million customers with AI stylists. The retail AI market is projected to exceed $20 billion by the end of 2025, which is growing 35% annually. And this is where the investment is flowing. Healthcare is seeing revolutionary impact from AI across clinical care and operations. Clinical applications, medical imaging and diagnostic assistance, matching or exceeding specialist accuracy, personalized treatment planning, early disease detection and prevention, clinical decision support systems, helping doctors make better choices, operational efficiency, hospital resource optimization, preventing bottlenecks, patient flow management, reducing wait times, administrative automation, freeing clinical staff, predictive maintenance, preventing equipment failures. Breakthrough applications, AI detects skin cancer with 95% accuracy, matching dermatologists. Drug discovery time reduced from 10 plus years to 3 to 5 years. Genomic analysis enables truly personalized treatment. Epidemic tracking and prediction for public health. Population health impact. Early warning systems for disease outbreaks. Big data analysis for public health insights. Optimized preventive care programs. Improved healthcare accessibility in undeserved areas. And this is not incremental improvement, it's transformative change in how healthcare is being delivered. Let me leave you with some strategic implementation framework. Technical foundation, master the three concepts, scores, classes, or clusters. Follow the structured 7-step development process we discussed earlier. Consider deep learning only for complex problems with sufficient data. Business strategy, apply this AIDR framework for every project decision. Focus on high impact, recurring problems where AI creates real value. Ensure strong data foundations before starting. Data quality determines the quality of your success. Industry applications. In finance, focus on front and back office automation with $1 trillion impact potential. In retail, optimize both customer experience and operations. In healthcare, improve individual care and system-wide efficiency. And what is the success formula? Algorithm viability and measurable impact and quality data and organizational readiness. This will be leading to AI success. Start small, prove value, then scale up. Be skeptical of the hype. Focus on specific measurable problems and remember, AI is a powerful tool for well-defined challenges. It's not a magic solution for everything. Thank you. I'm happy to take your questions. Please send me your emails. The email address is available. You can forward your comments, questions, and suggestions at this address. Thank you once again.